Good morning, everyone. My name is SITI SYAKILA binti MAHAMOD. Today, I will present our project, Plant Ground Derivative, which focus on analyzing all plant production using digital algorithm tools. Summary of the choose Bioscience problem is the main problem we are addressing is that monitoring all plant ground and predicting yield manually is difficult and time-consuming. This makes it hard for plantation managers to detect issues like disease or nutrient deficiency early. Our web tool solves this by using mathematical directives to track crop ground rate digitally. Importance of study this bioscience problem. This study is important for three main reasons. First, economy. Higher accuracy in predicting ground lead to better plum oil yield and higher profit. Second, food security. Plant oil is a major ingredient globally, so stabilizing its supply is crucial. Third, sustainability. Result data help optimize fertilizer use, reducing chemical waste and protecting the environment. Now, let's look at the interactive graph on our website as shown in the graph. When I click on Moon 5, the system displays a cumulative FFB yield of 27.75 kg per plant. First cumulative yield, the 27.75 kg show the total weight of fresh fruit bunches harvested from one tree up to Moon 5. The resulting line means the crop is healthy and productive. Third, the derivative. By using calculus derivatives, we can calculate the exact speed of fruit production at the specific moon. Third, discussion making. If the graph keeps climbing at moon 5, the current fertilizer plant is working well is it drop. The manager get an early warning to check the tree for pest or disease. Recommend one way to make this HTML better. For me, to make the HTML website better, I recommend fully integrated JavaScript library like cut.js. This will change the static cut into fully dynamic and animated graph. User would be able to zoom into specific moon and toggle between total yield and the derivative rate easily, making the data much more interactive for planters. That's all for me. Thank you.
Good morning, salam sejahtera to everyone. My name is ENICI anak MINGGAN. My number metric is F25A1604 and I'm the coder in this group. Today, I will present an interesting study titled Applications of Calculus Predictive Effect in the Crop Physiology of a Plum Year Dynamic in Malaysia. Our topic is about oil plum. In Malaysia, it is our golden crop. Usually, trees start producing fruit at age 3. The year recesses fast, reaches a peak and then slowly drop as the tree gets taller and nutrients are harder to transport. The big question is, when does growth slow down? When is production higher? And when should we replant? Using real data from MPOP and FERDA, we create a mathematical model to show this pattern. The yield function is fx is cubed negative 0.006 x cubed plus 0.15x squared plus 0.5x. And the rest of the chance is f prime of x squared negative 0.1x 1x x squared plus 0.30x plus 0.5. Here, X is the age of the tree, from 3 to 25 years old. Part importance of studying this bioscience problem. This study is very, very important. It helps us manage plantations better, plan harvestings, and control costs. It guides us to make smart business decisions, knowing exactly when to replant so we do not lose money or replant too early. It also helps our countries take a top produce and show that smart like cochlears as a critical tool for agriculture and that is just not theory. Okay, let me explain about the graph. First, we calculate the L, F of 10. It is negative 0.006 multiplied by 100,000. Sorry, it is negative 0.006 multiplied by 1000 plus 0.15 multiplied by 100 plus 0.5 multiplied by 10. That is Q negative 6 plus 50 plus 5. So the result is 14 tons per hectare per year. Next, we find the rate of change f prime of 10. It is negative 0.01x multiplied by 100 plus 0.30 multiplied by 10 plus 0.5. That is Q negative 1.x plus 3 plus 0.5. So the result is 1.7 tons per hectare per year square. The numbers test of the three conditions. Just you like in the graph, if f prime of x is more than 0, like our example of 1.7, here is still going up and the tree is growing well. And then if f prime of x is to 0, here is at the highest point. This is the best age for production. And next, if f prime of x is less than 0, it starts to drop and the tree is becoming productive. And the last, if f prime of x is less than negative 1.0, it is dropping too fast. This is the exact time we must to replant. So all this information is available because it comes from official record and real plantations data. So my recommend is to make this HTML better. I suggest to improve our HTML web page. We should add an interactive graph and automatic calculation system. Right now, it's only show formulas. If we add the graph showing support curve and a bot where user can tap any X to get the result instantly, it will be much easier to understand and very useful for studying and what student or firms. I think that is all for my presentation. So thank you very much.
Hello, my name is Ahmad Syahir Izzat bin Zulkifli. My matric number is F25A1856. Today I will be presenting interesting application of biological mathematics in agriculture, especially looking at the reactive Malaysian beef production using realistic growth parameter from the Malaysian Agriculture Research and Development Institute MAHD. Okay, two summary of the chosen bioscience problem. The bioscience problem we are addressing is how to track and optimize the growth rate of Kedah Kelantan crossbreed cattle. Livestock manager livestock manager need to maximize feed efficiency, knowing how much weight the animal gain daily. This cattle follow MOHD or shape S growth curve. Uh, if we look at the standard weight function (FF), it only tells us the total weight of animal on given day. X doesn't show us how fast they are growing at any exact moment. Number three, importance of studying this bioscience problem. The importance is in livestock management. Feed costs are one of the highest spent by using calculus and feeding directive. FX we can calculate the average daily gain, which represent the exact rate of growth on any given day. Crucially, this allows us to pinpoint the inflection point, the specific day when the animal growth rate peak by identify this peak. Farmer can optimize high protein feed allocation exactly when the cattle need it most, and adjust their strategy before they grow naturally. Begin to taper off the save money and get cattle market ready efficiently. Okay, number 4 point that I will show you is the day we move to number 3. We move to number 4. What I will show here select timeline is day 400. The curve of variable cattle weight FX solid green line, as you can see here. This represent the total weight of the animal in kilogram kg. Plot against the left-hand y-axis, it clearly displays the sigmoid F-shaped growth structure. It starts relative flat curve upward steeply during the rapid growth phase and began to taper toward day 400. Green road F at dash orange line here. This line represents the average daily gain in kilogram per day. Plot again right hand y-axis. It displays a bell-shaped cross that show exactly how velocity of the animal weight gain change over time. Okay, for the how to we move to number 5. Recommendation to make the HTML better. To improve the HTML page, I would recommend adding an interactive real-time graph component using JavaScript library like JS. While the text beautifully explain the mesh, allowing the user to see together visual chart where there can be between the S-shaped weight curve FF and the bell-shaped reactive curve FF or hover over the curve to instantly see inflection point would make the data reference far more impactful and easy for a livestock manager to interpret at a glance. Okay, that's all from me.
Good day everyone. Today I will present a fascinating application of biocalculus in the field of animal husbandry. We are specifically looking at modeling the weight gain of Malaysia indigenous Kedah Kelantan KK cattle. By using differential calculus, we can move beyond guessing and enter the era of precision farming. My name is Siti ARFAH binti Muhammad AZIZI, and I specialize in the intersection of mathematics and agriculture science. I believe that data-driven insight are the key to modernizing and ensuring industry and ensuring sustainable domestic food production. The bioscience problem, the primary challenge in beef production is that growth is non-linear. Cattle do not grow at a constant rate. They follow a biological S-curve without a mathematical model. It is difficult for farmers to manage resource efficiently across different life stages of the animal. Important wise of study, why it is important. Kedah Kelantan cattle contribute significantly to our domestic beef supply. By analyzing growth curve, we can optimize the return on investment for feed and determine the most profitable slaughter time. This is precision management in action. Let's dive into the core logic of our study. The cubic trajectory. We represent the growth using a cubic function. This specific model accounts for the acceleration and deceleration pace of growth. You will notice that above month 0, the model predicts 25 kg, which is the standard birth weight for high quality Kedah Kelantan cattle. To find the speed of growth, we use the Kelantan cattle. To find the speed of growth, we use the first derivative. In animal science, we call this the average daily gain or ADG. This derivative allows us to see the instantaneous growth rate at any month of the cattle life. As request, let's look specifically at month 9. This is a pivotal adolescent stage. By plugging into our weight equation, we find that the cattle reach nearly 100 kg. More importantly, the derivative tells us it is growing at a rate of 11.34 kg per month or roughly 378 gram every single day. Interpreting month 9, what does this data mean biologically? Month 9 is a phase of high momentum. The animal is highly efficient at converting nutrition into muscle. For a farmer, this is the golden window where high quality feed has the highest impact on future year. To make our current HTML application even better, I recommend prediction slider. This will allow a user to input different feed quality variable and see the growth curve shift in real time. This turns a static chart into a powerful decision making tool. In conclusion, biocalculus isn't just a classroom exercise. It is a biological clock that tells us exactly when to act to ensure the best health for the animal and the best profit for the farmer. That's all from me. Thank you.
Simple